first off want to thank everyone. Start out by saying thank you for joining the session. The Catalyst Wireless Migration Series is an ongoing webinar that we host, and you'll see a little bit more about that here in a second. As of today, we're going to be doing session 3, which is talking about deploying Catalyst 9800 in the cloud. It'll be around the private and public versions of our wireless LAN controller capabilities. All right, so on the first slide here that we see is basically the Catalyst 9800 wireless migration series that I just mentioned. You can see that a few of them have already happened. Basically, they are kind of building upon each other. So the first one was the introduction sort of to the 9800 with the migration overview and best practices. We moved on to the Flex Connect deployment. And then today we'll be talking about deploying the cloud version of it in private and public. If anyone would like to see prior recordings and the presentations themselves, you can view those at the bottom link on this slide, cs.co/9800 migration. Again, the slides and the presentation itself will be recorded and posted there. So, as you can see, these two handsome gentlemen right here in the top right, one of them is not me. I always do aspire to be as dapper as my co-presenter on the right there, but my name is Matt Gasparo. I am a solutions architect here at Cisco. I've been with Cisco almost 15 years. I came to Cisco through the Airespace acquisition in 2005. So I've been through a very long journey and a very great journey of the wireless platforms. And as you'll hear more about today with the cloud and cloud version of it, I think you'll be very interested in knowing all the new capabilities that you get with this new version. With that being said, I do want to just give a second to my co-presenter, Jonathan Grimm, and let him present himself.
Hi, team. Hello, I'm John Grimm. I too am a technical solutions architect, and I'm looking forward to showing you the awesome capabilities that we have with the Catalyst 9800 in our public and private cloud offerings. Matt, back to you.
Awesome. Now, as Erica mentioned, under what we call our Wireless Center of Excellence, we have a number of wireless technical solution architects also on the call today with us. They're panelists, and they will be fielding most of the questions in the Q&A. Again, that's going to be in the Q&A section if you have any questions going on. So in the first part here, we are going to talk about the Catalyst 9800 Cloud as an agenda. We're going to get into an introduction primarily around just reintroducing. If you've not seen our 9800 series platforms and the solutions around it, I will lightly touch on that area, as I think other people have done in some of the other presentations. The deployment models that you would get to utilize for each of those platforms. And then more importantly for today's session, we're going to get into details about the private and public cloud version. So part of the session goals that you should get out of this is the innovation and preparation for using the cloud version of the Catalyst 9800, along with some high-level design capabilities. And then most important is our best practices on how to use them. So with that being said, let's start out with, what is the Catalyst 9800 series wireless LAN controller? So it's built off of roughly about 15 years of wireless innovation. I mentioned I've been here through the entire journey for the most part. I wasn't here when the original AeroNet stuff was around, but basically everything that you see in our next generation wireless LAN controller platform is built off of a long history of technology. And one of the reasons that we've made this transition to iOS XE as the underlying operating system around the platform is because it starts to provide more things like open and programmable functionality. You'll see that here in a few minutes. The trustworthy solution, again, tried and true. It's been out for a long time. We've been doing this for a long time. It's not something new to the industry, but it does have a lot of underlining stuff that is been around for a long time. And then lastly is the modular operating system. One of the things that we wanted to get out of this, and you'll see here in the next pillar, is the always on capability. talking about things like in-service software upgrades, the ability to do an update with no disruption to your end user end devices, rolling out access point upgrades. This is something that I think a lot of customers have struggled with for many years, is being able to update their access points with code, but also finding that nirvana when doing it to how much disruption do they provide to the environment, trying to do it offline. So now we're trying to get to the point where we can do this in line with the inline service upgrades, and also providing a stateful upgrade and in service to the end users. And then the last one there, seamless adding new access point models to the existing code train. So one of the things that we want to be able to do is allow customers to adopt our new access point models, but not have to upgrade the entire infrastructure or software operating system to adopt that new access point model. And that's really around the ability to get access point pack files to update that. One of the things that we do when we talk about, deploying a wireless network is we want to always make sure that we adopt new security functionality. And one of the things that I think this platform brings to the table that a lot of customers have been looking for is the ability to look at encrypted traffic analytics. If you're not familiar with that, I encourage you to go online and look that up at cisco.com. ETA is a functionality where we can look at encrypted packets for malicious traffic. It's a very neat technology. The other ability there is automating macro and micro segmentation through software-defined access. If you're not familiar with that, that really is around virtual networking capabilities in the Catalyst platforms. And then lastly is WPA3 support. We always want to make sure that we're supporting the latest and greatest encryption technology for wireless clients. Lastly is deploying it anywhere, right? We want to be able to give our customers the ability to put the 9800, whether it's on-premise, as we've traditionally done, privately in their data centers, or in a public cloud, which we'll talk about more here in a second. Supporting things like GovCloud, which gives our federal customers or government customers the ability to use cloud services is a very important thing nowadays. And lastly is scaling this out. One of the things we want to make sure is that we allow our products and our customers to adopt it and provide a scaling capability. So when we talk about the 9800 wireless LAN controller, as you can see here, we've developed a number of models and platforms depending on the customer's requirements. On the bottom left, you'll see the 9800 embedded wireless LAN controller, which is basically a virtual version of the controller running directly on an access point, really designed for smaller environments or distributed environments where you need to run a lower amount of access points at a site. Moving your way up, we have the embedded wireless LAN controller, again, virtually running on a Catalyst platform. We do support this both in fabric and in non-fabric mode. The 9800L is our entry model kind of scenario where you want an on-premise controller with the supportability of 250 access points at the base, up to 500 access points capability. As we move our way up the stack there, you see the 9800 Series 40 and the 80 are our high-end platforms, and those will support anywhere from 2,000 to 6,000 access points. Below that line is really where we're going to focus the rest of today on, which is our cloud offering. And that both means not only private, but public. So as you can see where these two types of models will sit, the 9800 CL can both be developed as a minimum of supporting 1,000 access points to as much as 6,000 access points. And again, this is very highly scalable as you want to use the solution. So let's talk about some of the deployment models that you would utilize the 9800, and we'll talk about the definitions and terms around private, public, and hybrid. So the first one is around private cloud, the 9800 being used in a private cloud version. And we call this basically, you have exclusive access to the resources. Typically, this is in your own data center or a colo shared data center where you still own the resources or you're sharing the resources, but you still have some direct access to these resources. The resources are typically on-prem, as mentioned, or hosted by a colocation provider, and the WLC is running as a virtual machine, so you're not deploying the physical controller seen in the last slide. The public cloud version is where you don't own any of the infrastructure that you want to deploy the virtual controller on. And this would basically be what we call infrastructure as a service, where you're going to run it in a cloud offering like Amazon or Google. And you'll see more about that here in a few minutes. The hybrid is really those customers that need a little bit of both. They're maybe teetering on still having on-prem solution needs for certain particular deployment models, or you need public cloud to be able to utilize either a public first or public cloud first model, or you're starting to dive into using public cloud services. So the 9800 cloud design options that we have basically are two different models here that you see. The dedicated local controller basically means you're running that virtual controller as a dedicated resource, and you're tunneling the traffic of the clients back to the wireless LAN controller. Today, this model is only supported in the private cloud option. On the right-hand side, you see the remote controller, which we call Flex Connect. If you're not familiar with Flex Connect, the session 2 that was done a few weeks back actually goes into great detail about how that solution works. And the light of it basically is that the data traffic remains local to where the access point is connected to. And usually that's at the branch office or in a distributed fashion or an environment. One of the things that we want to make sure that we support in both the dedicated local controller, the remote controllers design scenarios, is the ability to deploy policy, automate that policy, provide some level of assurance information so you can see what's going on with the clients and the platforms, always providing security, integration with our identity service engine technology. If you're not familiar with that, that's basically has a lot of different things like authentication and the ability to integrate into our software-defined access environments. And lastly is location service. We don't want to let that go. That location service is an important item to a lot of our customers. So let's talk about remote controller, because that's really what most customers are going to utilize the 9800 virtual controller for. So as you can see here, this wireless controller is deployed centrally, right? So this will sit, as I mentioned, in a data center, co-location, or potentially in a cloud offering. And you will be able to deploy this in a way that it can support access points across branches, even in an enterprise environment where you don't need to have a local controller for needs. It would be able to support those types of design models. Typically, these are scenarios where you have about 100 access points in a Flex Connect group. Again, you can hear more about Flex Connect groups and why they're used and why you would segment and use Flex Connect groups in the prior session. Most of the features and functions are around layer 2 roaming only as of right now, and then supporting a standalone mode operation. So we want to make sure that the platform is highly scalable. As we said, we can allow you to go from anywhere from a few hundred access points up to 6,000, and then scaling that even beyond 6,000 by using other methods and high availability options to get further scalability above and beyond that. Essential management capability is always important to our customers. We always hear, we don't want to be able to go into each of these devices and manage 6,000 APs on one of them, go to another one and manage another 6,000 and so on and so on. You need some way to centrally manage that. And that can, again, be done through technologies like DNA Center, where you can deploy and automate those functionalities from there. One of the things that we always stay conscious of, though, when deploying a virtual controller is the WAN guidances. Because again, where you're using and deploying the controller, a lot of times is not going to be local to where the access points are. So we do have some minimum requirements in there, things like bandwidth per AP, so we can get amount of traffic information from that access point to the controller, things like client connectivity and some session keys and things like that. Latency, 300 millisecond round time tip is the recommended. We don't want to go above and beyond that for things like data and voice and data. We're at 100 milliseconds. So where would someone like yourselves use this type of technology? And some of the traditional use cases that we see our customers using this would be our Flex Connect remote wireless LAN controller. That was where we spent a couple of minutes talking about the different deployment models just a few seconds ago. Again, this can be utilized in public and private cloud. The remote teleworker solution is really around, think about today in the world that we live in, the need to deploy, a wireless technology at your employees' sites, or even at a remote place where you have a few people working. You want to be able to tunnel that traffic back to your organization so they can get access to the resources in a data center that's owned by you guys, right? So that we call this the remote teleworker wireless LAN. Today, this is only supported in private. Makes sense because in the public cloud version, we don't tunnel the traffic, the data traffic, back to the controller. We now allow for guest anchor technology, so you can use this controller and virtualization in a guest anchor fashion. If you're familiar with our foreign and anchor capabilities, this is the ability to tunnel the data traffic from one controller to another controller and terminate it traditionally at another place. Typically, you see this in a DMZ environment. We do support the local controller functionality there, as you can see. And then lastly, one of the things that probably is going to be highly utilized is the ability to test and do a proof of concept of the solution and the technology. A lot of times customers don't want to just go out and buy our controllers immediately, or they don't have the funds to immediately upgrade. This gives a great way to get the technology into the environment, do self-education with the interface, do some lab testing, and practice a bunch of things with changing the configurations, not harming anything. All right, so some of the deployment options, right? As we get further down into the private cloud version, I'm going to talk primarily about private cloud, and my co-presenter, Jonathan, is going to talk about public cloud. So let's start with private cloud and what are really the value propositions that you get with deploying it in your own environment. So one is that you can basically put it where you want it and how you want it, right? So, do you want to use a particular type of hypervisor? Do you want to tunnel the traffic back? Do you want it in Flex Connect? It provides just a number of methods that you can use that technology in your own environment. Today, we do support a number of AP models, right? And depending on the code version, I'm going to always recommend that you go to cisco.com, you go to the release notes for the version that you would like to deploy or test, and ensure that you look at the supported access point models under there. We always provide a great level of detail on the interoperability and the level of access points models that we support in that version, along with supporting local mode, which is where we tunnel the traffic back to the controller. Mesh, if you're not familiar with Mesh, that's the ability for access points to communicate wireless to each other. Flex Connect, which we're going to talk more in depth about here in a second, which is the ability for the traffic to be terminated at the connection point, or the ability to support the new software-defined access model. Feature parity is pretty on par with the appliance models. We haven't really deviated too much as we have in the past, where the virtual controller did diverge a little from the physical controller. There was some feature gaps between them. We've tried to keep true feature parity with the virtual controller and the physical appliances. And you'll see that there's an actual feature matrix, again, posted on cisco.com about that. Now, as you can further see here, one of the things that we want to do is we wanted to be able to support a number of types of hypervisors. And I'm going to touch on each of these further in detail here in a minute. But, the ability to give the customers that, how you want it, where you want it, really allows you that extensibility into the types of hypervisors that most enterprise customers use today. And then again, the AP models that we support there for the most part. So let's look at some of the differences between our traditional AirOS virtual wireless LAN controller and what we brought to light with our new Catalyst 9800 cloud controller. As you can see here, some of the things that really are helping our customers deploy this in a much more flexible method is stateful switch over and high availability, not only in the platform itself, but to the clients. The ability to support multiple modes. As I mentioned, and we talked about here in a couple, we've seen in the prior slides, the ability to support Flex, Local, and Fabric. The ability to support this in a anchor solution, right? So DMZ environment where you want to tunnel potentially guest traffic, BYODs scenario. The ability to look at automation through DNA Center, supporting that ability to say, hey, I want to onboard this and I want to manage it through innovation that you guys given us through DNA Center. It's important to look at that, the throughput numbers that we support here are a lot higher than the virtual controller was, where it was at 500 megs. We now support up to 2.1 gigs, and you can extend that even beyond 2.1 gigs, as you see on the right-hand side here, with some of the caveats like using SRIOV, which can then allow you some pass-through functionality, offloads network packet transitions from getting that off the CPU and memory, directly passing it through to the network card. Bigger scalability, right? Almost doubling all the numbers that you see of the prior platform, getting up to 6,000 APs on one virtual appliance with 64,000 clients. And I think what's most interesting, if you see here at the bottom, is the installation image. One of the things that we did with the virtual wireless LAN controller at AirOS is that you had to know, the image type for the particular platform. We've gone to a single image type that allows you, the ability to use that flexibility for different hypervisors. So some things to note, looks a little bit like the last slide, but some things to note, because it's not in there, is support for prime infrastructure. Yes, you can support the 9800 cloud offering, the on-prem private cloud version, by using it in prime infrastructure. On the right-hand side, some of the things that I think are notable here is the N+1 support. This is something that we've done for over a decade, supporting the ability to scale out the platforms and provide a level of redundancy that most customers like and need from our platform, and doing that in a virtual platform. As you can see, the anchor and foreign controllability is capable on the virtual version. And more importantly, down here in the bottom right here, you see location services, being able to support DNA Spaces and Cisco CMX capability. So some of the things that we've learned from deploying private cloud are some life lessons that the field has learned, our customers have fed back to us, things that we want to make sure we share with you up front about deploying it. First off, it doesn't support hyper-threading, not needed. A single core mechanism is needed, and dedicating CPU resources is a very important thing in these platforms. You'll see more about that when we get to the individual platforms. Don't exceed the client throughput. Again, these are things that are very important because you don't want to over consume the resources on the virtual platform. Physical ports, how you map those with virtual switches in each of the types of hypervisor. We're going to touch on some of the caveats around that. Being able to make sure you don't over consume some of the upstream switch TCAM space information with memory on there, and then hypervisor resource optimization. We have a ton of things in there that we can highlight. So one of the things that's very important to identify, and this will be applicable to most all of our virtual private cloud versions, is that by default, you do get 3 gigabit Ethernet interfaces with each virtual version, private cloud version. The first one is always, for the most part, dedicated to out-of-band management. It's very important to note that that is out-of-band management. The second gigabit interface is really the interface that you will utilize to terminate access points to, and it's where wireless clients will be terminated to if you decide to bring traffic back to the environment. It's where you can trunk and provide a trunking capability. And then the third one will be the redundancy port, we call. That's the ability to synchronize between 2 controllers running in a stateful switchover capability or a high available option. Oh, and one last thing I always like to mention there is don't map, make sure you do map each of these interfaces to a different network. One of the things we don't want to do is create a traditional spanning tree or forwarding loop in here. It's a very important thing. You would not want to get a call from your data center guys or someone involved in owning the virtual infrastructure saying that you've brought down the entire virtual server. So some additional things is that gigabit 1, using that as a service port, like our traditional service port on the physical platforms, this is designed as an out-of-band management. It does require you, if you need to be able to route to it in an out-of-band fashion, that you install routes that are targeted to this network. And then when you're configuring the trunking capability, which we'll talk about a little bit in each of the individual versions, you do need to make sure that you have VLAN trunking turned on, especially with that 2nd gigabit interface. A life note here about the certificate utilize. We highly recommend that you transition once it's installed from using the TP self-sign to a self-sign certificate that comes inside and moving that to the HTTP Secure Trust Point capability. So let's talk about a couple of different versions. Well, the first one we're going to highlight is the KVM version. Today, we support Linux distributions, Red Hat Enterprise 7.1 and Ubuntu 16.04 LTS. These are the minimum required versions to run the KVM version. And again, these are traditionally enterprise or server grade versions of the Linux distribution. You can see here that we introduced the operating system of the wireless LAN controller from 16.12 version to the latest availability of 17.4. You can find this on cisco.com, and you'll see that we have a small, medium, and large version. These will come more important here in a second. A thing to note is that there is a low throughput version and a high throughput version when deploying these, and you can see some of the nuances of why we have a low throughput and a high throughput. Traditionally, again, if you were looking at, if you're going to do a Flex Connect, you might not need the high throughput version because you're not bringing traffic back to the system. Whereas you might consider looking at the high throughput version because you're going to tunnel traffic back. And you can see the speed differences and taking advantage of technology like SRIOV that allows us to increase the throughput of the technology there, so from 2.1 to 5 gigabits. Some of the things to note about the file format options that you'll find on cisco.com is you would typically boot this as an ISO image found there, or you can additionally, we do have a QCOW2 version. So either of these two versions can be found. That will be your deployment capability. Once you have the virtual controller deployed, you can then upgrade to newer releases by just downloading the bin version and uploading it directly into the UI interface of the virtual controller through the bin. Some of the steps you might take in deploying the ISO version in a KVM environment, as you can see here, you would pick the IDE version there on the top. You would then pick where the ISO is available to the device. This is one situation where you do, because you are choosing the ISO, you do need to choose things like the memory and CPU and disk space needed to operate this virtual platform. It's important to note that you don't need to over subscribe resources. So don't need to go to 10 gig of memory or 16 gig of memory or 8 core process CPUs or 16 gig of data space, because the platforms are designed to only utilize what is the recommended minimum version CPU and disk space. When you get past selecting those, one of the things that you're going to see there now is selecting the customization to assign the NICs. So again, noticing that you have 3 virtual NICs in there, the Gigabit Ethernet 1, 2, and 3, assigning those to the service port, the management, and the high availability. Once you assign those, it will then push that into the hypervisor and make those interconnections capable there. We do support, and this is something that came available in our 17 release, is Microsoft Hyper-V support for Windows 2016 and 2019. Again, you can see similar numbers. We provide a small, medium, and large format, 2.1 gigabits supported, and the number of access points, 1,000, 3,000, 6,000, very much like the prior version that you saw with KVM. Things to note that are very important when you use Hyper-V are there are 2 generations of Hyper-V. And if you're not familiar with Hyper-V, generation 1 is really around legacy support, and generation 2 is more newer features and functionalities like Secure Boot. And when you deploy with generation 2, the default method of the boot environment is to put it in a Secure Boot. We don't support Secure Boot, so it's important that you go in and turn that off when using that by deploying that. We don't support console connectivity into it, meaning there are third-party applications that you can get to work with it, but you have to do a little work around to get those to work. As you can see here in the next slide, when you're doing the connections on the back end in the hypervisor, one of the important features to make sure that you turn on is enabling the MAC address spoofing. And basically, this allows for multiple addresses to be given on an interface. It's a very important thing. If you have this turned off, you will not be able to pass traffic on the management interface. And then lastly is VLAN tagging. An important feature and functionality that we all want to be able to support on there is the tagging. You do have to go in there and turn that on the virtual switch itself, not at the physical port level. To turn it on the physical port, you do have to log into the PowerShell of the operating system and run some additional commands so that you can support the trunking all the way through down into the operating system component. All right, so let's talk a little bit more about ESXi as the next hypervisor. Very similar like the other two. We supported this from 1612. All the similar, access point access point scalable numbers are there, 1,000, 3,000, 6,000. Same numbers with the clients, very similar on resources and, virtual switch at the very bottom there. We do support like the KVM model. We have a low throughput version and a high throughput version. Again, utilize features like SRIOV. We get the additional throughput, and some of the things that you'll see here that we're road mapping are VM layer 2 lag at the very bottom. There's a lot of things that you have to look at when you're doing things like SRIOV that you can't do, like vMotion or doing snapshots of the images. There's a lot of reasons for that. We have a lot of guidance in the release notes for why that doesn't work. But if you don't use the SRIOV features and functions, and you look at some of the other things with just using the vSwitch, you can see that you do get the capability of doing vMotion and vSwitch and snapshots. Apologize. And again, this is just to note, just like I said in the very first deployment, the life lessons learned, it's very important that you map these into individual, networks on the vSwitch, so that you don't get things like routing loops or switching loops, in there. So we want to make sure we highlight that again here. One of the additional things using an ESXi so that we can pass multiple MAC addresses downstream on the trunk, and so that we can receive requests back on that trunk, is it is required to turn promiscuous mode from reject to accept, and additionally the forged transmit for reject to accept. Again, the promiscuous mode is for downstream, the forged transmit is for upstream, things coming back, going out. And one of the things that we want to make sure is that we get that traffic back and forth, and these are very important things. Now, if you can't do this because there are other VM instances attached to a particular vSwitch, you can create additional vSwitches and then assign this port group security methods to a different vSwitch using the same physical interfaces that other VMs may be using. So some of the deployment options, as you can see here, we want to make sure that you can deploy this with no VLANs being shared, right? And you can see this on the left, where the virtual wireless LAN controller is directly mapped to a port group. That vSwitch then can be, is possibly shared, and then you're directly tying that to a NIC on the network side of it. On the right-hand side, and you can see we're matching that. You make sure that you turn on the promiscuous mode to accept and the forward transmits to accept on both methods. This is allowing you to do things like virtual teaming on a particular vSwitch where it's dedicated resources versus the other VMs on there might be using different services, but also sharing things like VLAN numbers in there. Lastly is our ability to have multiple versions of the private cloud 9800 running on a on a particular server, and allowing those to work together, either in a high availability mode or independently in an M+1 mode. With that being said, I'm going to go ahead and turn the demo capability over to my co-presenter, Jonathan. If you wouldn't mind, go ahead and taking the ball and showing a little bit about how this works.
Great. Thanks, Matt. Hopefully you can see my screen. Perfect.
I can absolutely see it. You're good to go.
Great. Thank you. Well, what we want to do for the team right here now is a demo. We want to show you how you could deploy the CAT 9800 cloud on ESXi. And we're taking it a step further here. We want to show this being a HASSO pair. So you'll actually see a primary CAT 9800 and the standby CAT 9800, and we'll deploy both of them at the same time here. So here we go. First, you're going to see me log into vCenter. We're going to deploy an OVF here. And what we can do is we're just picking the OVF and we're going to name it right now in vSphere. Now we're going to basically validate that and import the data. Next, we're going to begin to see how we begin to provision this. So here, if we take a second here and we take a look at some of the information, we saw those, the ability to have those profiles that Matt was talking about earlier. The ability to pick, hey, we want to pick 1,000 APs, 3,000 APs, or 6,000 APs here as we're doing this. Now we're actually picking the individual interfaces. Remember, paying attention to the fact that we want to have them on different networks here, not to create a network forwarding loop. What I'm showing right now is basically the provisioning guide here. So basically, if you're using vSphere to deploy this, we actually have a guided template for you to fill in, and we'll do basic provisioning of the device for you. This helps when we get into day zero deployment method shortly after deployment here. So what we're just seeing is me adding, the IP address of the out-of-band management, the network username, to access it, and the enable password. Now I'm deploying the secondary CAT 9800 controller here. This is going to be the HASSO standby for the one that we just created. So we're doing both at the same time here. Normally this takes about 15 minutes to deploy. As you can tell, we're speeding it up just because of available time here. So here again, we're picking the individual interfaces here, making sure we're mapping them to the correct vSwitches. We're also going through the same configuration steps that we did before with the primary. And as we keep stepping through this, you're seeing, this is very easy to add this information here. Shortly in a second, we're going to see, we're going to hit next, and we're actually going to begin to deploy this. So this is taking the OVA image and then bringing it onto the hypervisor here to deploy it. So in a second, we're actually going to boot up the primary controller for the first time. We're going to go into the web console. You're going to see a standard boot up sequence here. We're going to see it basically unpacking all the information, installing the binaries automatically. We're also going to do this for the standby very shortly as well. So once this is operational very shortly, we're going to be able to hop into the web browser here and then actually start the day zero provisioning script. This day zero provisioning script is the same provisioning process you would use whether it's a physical on-prem controller or a virtual controller that's on a private cloud or public cloud. So what you're seeing here is basically me going through doing basic configuration, setting up the wireless management interface for the device, setting that up, and we're going to be able to also in a second add the HASSO capabilities here. But this first step is basically setting up the trust point for the access points to join. Remember, this is a virtual hardware. There's not a physical trust point that we can use for certificates to anchor. So we had to create that using a virtual trust point here. So what you saw right there was just the initial day zero provisioning of the primary controller. It now has usernames, it has IP address, it's configured for the country that the APs are operating in, and it's configured to be a HASSO primary. Now we're going to go in here. We're actually in the wireless LAN controller that we just configured. We're going to change the priority of the chassis. This is the primary. I want to make sure this, in an election process, this is the primary. And once we set that up, it's going to reboot. Now, what we're going to do is change our focus to the standby CAT 9800 controller. So we're going to go through that same day zero configuration process, but it's a lot less that we have to fill in because this is a standby. It's going to get its configuration from the primary. So what we're doing here is basically saying this is the HA SSO interface. It's gigabit 3. The wireless management VLAN here in this environment is 104. And then we basically map the same IP addresses that we put in the primary. Now we're going to basically commit the information. The Cat 9800 cloud is going to reload. And we're actually going to see the two wireless LAN controllers join, and we'll see it actually be an HA SSO pair. So again, my apologies. We did accelerate the video here just because of the amount of time that we have here, the amount of content that we want to go through. But what we can quickly see here is, both units have booted up, they have joined. And now if we look here very quickly, we'll see here, it's an SSO mode. And if we look in the system here and in redundancy, we're actually running an active and standby hot. So the primary and the standby controllers are operational and they're running. So again, this takes about 15 minutes of you just clicking through the stuff here to get a primary and a standby full redundancy in your environment here. So with that, we talk a lot about the private cloud, but we also have a public cloud offering of the Cat 9800. So many customers are adopting a hybrid cloud strategy. For them, shifting the wireless LAN controller into the public cloud makes complete sense. And why does it do that for them? Well, we're eliminating the hardware overhead. So think about how much cost is required to actually maintain a virtual server infrastructure in your environment. You have hypervisor cost, physical hardware cost, cooling, power. So with a public cloud option, they can lift that same infrastructure as a service offering up into the cloud and eliminate that cost. The other thing, and Matt hit upon this very gracefully here, is our elastic scalability here. So let's say you deployed, 1,000 access points, and now you bring on a new branch to your site. You're like, I need to, basically add this new, branch here, but I'm already at capacity. Well, what you can basically do is instantiate a new Cat 9800 in the public cloud, move the configuration over, and you instantly scaled up to the next level there very easily. The other thing that you can begin to do is retain the customization of the on-prem solution here. So one of the great things is all the capabilities that we had, with configuring RF, configuring the SSIDs, a lot of those capabilities that you would see on the on-prem solutions are available in the cloud offering here. Lastly, ease of setup. We're going to run through a demo here, and we're going to show you that same process that we use to basically boot up that private cloud version is the same that we have for a public cloud version as well. And that day zero script makes it very easy to have a wireless LAN controller ready to roll on day one very quickly here. So the other huge benefit that we get from public cloud is its ubiquity. Think about it. So you have the ability to have regional deployment options that are plentiful depending on where you live. So you can deploy the Cat 9800 closer to your branches and not have to incur the latency of maybe centralizing it. If all your APs are on the West Coast and your data centers on the East Coast, you can cut down on that latency footprint there. So when we take a look at the public cloud offerings for the Cat 9800, it is infrastructure as a service. We currently support Amazon Web Services and Google Cloud Platform. The Cat 9800 is offered in the marketplace for both public cloud providers. Please engage your Cisco account team if interested in a Microsoft Azure offering. Product management will take this direct feedback under advisement. A managed VPN is required between the public cloud provider and your branches. We use the VPN to extend secure connectivity for the already encrypted AP control plane. We also use it for radius authentication and management access to the Cat 9800. We understand this adds a layer of complexity for some customers, and we are starting a beta trial for a public accessible interface with the public cloud providers here. So if you're interested in an option such as a public offering that has an exposed, a wireless management interface, please message us privately in the question and answer room here. We'll take this back to product management. The other thing is, as a reminder, the public cloud offering of the Cat 9800 only supports FlexConnect local switching. We did this because cloud providers do not support layer 2 trunking on virtual servers. Also, with a public cloud provider, you're charged for bytes in and bytes out. So if you're centralizing the client traffic, this could be pretty costly unless you had your own private interconnect. But still, we only support, you know, FlexConnect local switching with the public cloud offering. The same goes for Guest Anchor in the public cloud. It's not supported for the same reasons. So with FlexConnect local switching, you can easily provide guest access at your branch using an isolated VLAN and direct internet access with your SD-WAN. So that's an easy use case that we can quickly turn up. From a redundancy perspective, we only support N+1 redundancy. The good thing, though, is FlexConnect local switching has built-in survivability capabilities, as the AP rejoins a Cat 9800 in a different availability zone or region. So those clients that are associated to that access point are not disconnected as we fail over that connection from the access point to the N+1 Cat 9800. Just a call out here, licensing for all Cat 9800 deployments utilize smart licensing. So you can easily access your license pool no matter where you deploy the Cat 9800. Lastly, from a centralized management standpoint, we don't officially support DNA Center or prime infrastructure with the Cat 9800 public cloud offering. It works, but we haven't validated the solution. We had concerns with increasing customer transport charges from the telemetry exchange between the Cat 9800 and Cisco DNA Center. As a reminder, you, the customer, have to pay for network transport usage to the public cloud provider. So when deploying a Cat 9800 in a public cloud provider, the access point and the client scale capabilities are the same between Amazon Web Services and Google Cloud Platform. We offer the Catalyst 9800 Cloud in 3 profiles. We gain AP and client capacity when we add more virtual resources to the solution. This allows you to easily scale up your environment by deploying a new Catalyst 9800 Cloud with a larger profile. So we'll take a deep breath here. So for many wireless engineers, this is your first interaction managing a public cloud solution. Here are some terms that are common between all public cloud providers. As a side note here, our demo will help to reinforce these concepts very shortly here. So as we take a look, the top concept here is the region. So a cloud provider has distributed data centers across the entire globe. Each region is independent and separated. For example, I'm on the East Coast of the United States. I have the option of, with Amazon, in the Herndon area, or even Ohio. There's even options out west as well. These are called independent regions. Next, from a hierarchy perspective, this is us going from the outside and drilling in. Next is the availability zone. This is basically a fault-tolerant area within the region. So basically within, for example, Herndon, I have these different fault-tolerant areas that I can basically have another Cat 9800 in that region, and it would be protected in case there's a problem with the primary. The next is the virtual private cloud. This basically is your customer private network in the cloud. And basically, when we go through the demo, you see you set up a supernet, basically a supernet of IP address that you're going to use for your virtual compute in there. And then that next step is that subnet. That's where we basically set up multiple different subnets depending on the needs of your applications or infrastructure in the cloud. Again, routing table, no different than what you're used to today. Basically, we're just taking that same concept and bringing it up to a virtual compute perspective here. Having a routing table that helps you to access different subnets based within your VPC. Lastly, security groups. We're in the cloud. We need to make sure we have security. And there's no difference here. So when we're going through the demo here, you're going to see me actually apply a firewall rule set directly to the Cat 9800. And what that basically allows me to do is say which protocols I want to support coming into that IP address that we assign, but then also what subnets that we want to filter that based off of. So let's dive into a hypothetical deployment of the Cat 9800 cloud and a public cloud provider here. So let's take a look here. At the high level here, we have your network on the upper right-hand side. That basically has your access points, it has your Active Directory, it has your Radius server, ICE, and then you have your router. Well, what we have to do is basically establish a VPN connection from your branch to that cloud service provider there. And we establish that connection using a VPN gateway. So what we see on the left-hand side team here is that same concept we talked about in the previous slide, the region. So we're going to deploy a Cat 9800 in a specific region, whether it's in Amazon or Google Cloud. And then we establish that virtual private cloud that we set up in there. And within the virtual private cloud, we're going to create a subnet. And that's that specific subnet that we're going to basically instantiate that Cat 9800 controller in there. So one of the things that we'll do, and you'll see this in the demo, is once we establish, the Cat 9800 and all these other resources, we also set up connectivity to that virtual private network gateway. This allows us to have that connectivity to all our branches very seamlessly and very easily. So one of the things is these cloud service providers also require you to have a secondary tunnel. So we'll see when we're doing the provisioning of this, that tunnel that we build between our branch and the cloud service provider, there's actually two separate tunnels that we can build in here to ensure that we have resiliency. So this routing that we set up here, by default, all this information here is private. This is what I want to highlight here. The typical solution that we support here is there's nothing internet accessible here. Everything's going through that virtual private network gateway that we have here. So there's very minimal chance of anything bad going on here. And we have that virtual routing table here to help us with that as well. So some other important things to highlight here are public cloud only supports layer 3 interfaces on the Catalyst 9800. The service providers basically do not have the ability to trunk different subnets to an elastic compute there. Public cloud IP allocations are done via, DHCP. We don't have the ability to allocate some of these, but what we can do is actually configure certain addresses, and they basically show up as a DHCP reservation. We'll see that during the demo. And lastly, the Cat 9800 controller only supports one interface when deployed in the public cloud. So management access and APs use the same IP address. No out-of-band capabilities. This is where that security group comes into play here to ensure that if you need to filter access to different components to that controller, you do so in that security group tag there. Okay, team, we have another demo that we can step through here. So what we wanted to do is, as we said, this is the first time for a lot of you that you're touching a cloud service provider. So all these concepts that I walked through might be a little new. And what we can do is basically in this demo is step through how do we create this environment before we even instantiate the Cat 9800. So I'll begin the demo right now. So first, we're going to begin. I logged into Amazon Web Services here, and we see here the EC2 dashboard. This is where the compute is. VPC dashboard is where I set up the virtual networking. We see on the right-hand side are the different regions that are supported within Amazon Web Services here. So what I did next was created a virtual private cloud. So this is basically that SuperNet address that I highlighted there, all the capabilities of all these servers that I could deploy down here. So what I'm doing now is showing you if I were to create a new virtual private cloud, this is, I basically name it, I set up the SuperNet for it, and then assign it to a specific region. Now I'm showing the different subnets that would reside in that virtual private cloud. Now we're creating multiple /24s here. And one of the things that we see in the section below here is availability zones. This gives us the ability to put that subnet in a different availability zone in that region, providing that redundancy. If we want to deploy a second Cat 9800 controller in that different subnet in a different availability zone. So as you can see here, this is very quick and easy to set this up once you understand the order of operations. So that's why this video is pretty beneficial in illustrating all these concepts. So the route table, this is basically how we do our routing within the virtual private cloud. One of the things is once we create the VPC and the subnets, we have to bind them to the actual route table for that VPC, which is what we saw there. Next, we're going to create the virtual private gateway. So this is network function virtualization. So these different functions that a network normally has are typically deployed as different components. In the virtual private gateway is basically the VPN concentrator that's going to be used to talk out to our branches. So what I'm creating here is a customer gateway. This is the IP address of the virtual, VPN system at your branch. So one of the things is with the system is I'm deploying on Amazon's virtual private gateway. We do offer the CSR 1000V virtual router in Amazon and also Google Cloud. So you can deploy using DMVPN overlays, all the same technologies and command line that you're used to in a Cisco routed network. But here we're just basically creating the the VPN connection here. So I set up which routes that we're going to basically advertise across this VPN going back to my environment here. So these are the subnets that would be advertised at your branch, so that the Cat 9800 knows where to go to, which tunnel to take to get to it. So we have multiple different encryption options that we have within here. So if you want to see this, and tweak the configuration settings, you have that ability to do that. So one of the great things that the cloud service provider does is makes this VPN configuration very easy. You basically select what vendor your security device is or router is at the site, and then it gives you a strawman configuration that you can use to basically establish connectivity into your VPC from your branch. So obviously you need to configure that and modify it depending on your security requirements. But what we see here are the tunnels are up and operational after applying that to my virtual router at my branch. So now that we created that virtual private gateway, we need to take those routes that we have and basically connect them to the virtual private gateway so that we have route propagation, just like what you do today in your VPNs that you create. So that is us creating the virtual compute environment, basically setting up all the networking, setting up the VPN connectivity to your branch site here. So I know we went kind of fast, but once you see this, and we're offering all the videos that we just demoed here as downloadable collateral, so that you can review this in slow motion here and see this in greater detail. Plus, the same content that I'm showing here from an Amazon Web perspective, we have TMEs who have recorded their own versions of this data here and spend about an hour stepping through each step in each succession. So if you need a deeper understanding of what each of those components are doing, we provide that guidance for you to learn and get up to speed very fast. So the next part is, let's figure out how to deploy the Cat 9800. So we built the virtual environment. Now let's actually deploy the Cat 9800. So now we're going to go back to our EC2 dashboard, and we're actually going to begin by taking a look at this here. So we want to be able to create a key pair. So if you want to SSH into the Cat 9800, Amazon requires you to have an SSH key. So you can download it based on the format that your SSH client supports. It's very easy to create, and we'll see that during the building process. Now, here's the security group that I talked about. This is where I created a firewall rule set of the traffic I want to allow to that wireless management interface here to the Cat 9800. Now we're looking within the marketplace. The Catalyst 9800 Cloud is available in Amazon Web Services and the Google Cloud Compute platform, as an offering here. So right now I'm saying which region I want to deploy the Cat 9800 in, and then what size I want this to be, small, medium, or large. And basically we change the compute associated with that. What we're going to do is deploy using a CloudFormation template. This is basically going to step us through that same configuration script that we had with ESXi to basically pre-provision that wireless LAN controller in the cloud so that we can then begin to access the day zero startup script. So we're basically going to use the template, and we're going to set up the name of the controller, the username that we want to access it with, and then the management IP address if we don't want DHCP to assign that number for us. So we saw there, the SSH key we want to use and the security firewall rule set, that security group we want to use. Here's where we're setting the IP address of the wireless management interface. Now we're going to set the username and the password to get into the system. And below, we're just going to confirm, again, the size of the profile that we want to use here, how much virtual compute we want to dedicate to this. We're just reviewing some steps here before we deploy, and now we're going to create this. So in a few seconds, this is actually going to be ready for us to use. We're seeing it's creating the system, and it's basically building that up within our virtual private cloud. We're going to do a quick time shift here. And now that we see, if we switch over to the EC2 dashboard, we can begin to see the instances. So we see here this running. So we're actually building that up right now. Amazon's backend systems automated all this capability for us. And basically, we're going to have a system that's ready for us to use very, very soon. So the one thing I was doing, just because I'm impatient, was I wanted to see how long it took for us to actually have this instantiated here. So we're going to see me cut back between this and, come back to it in a second. But this really is very, very quick. So that scalability that we have here and that ability to bring the controller very quickly to your region, this is very impressive to be able to do this. So we're just running through what was provisioned as part of this. We see it's a private IP address, not a public IP address. This is all internal to that virtual private cloud and not exposed to the internet. So now we're going to actually do that day zero configuration, that same configuration that we do on all Cat 9800 controllers, whether it's physical, virtual, on-prem, or in the cloud. So what we see here is a paired down screen because we don't have as many interfaces that we need to configure as part of this, but we have the ability to basically set up NTP, set the clock. We could set up a SSID if we wanted to. Here's an important feature again, setting up that trust point for the APs to join. Now we're going to basically configure this. It's going to push the config to the Cat 9800, and then this is going to restart the browser session, and then it's going to be available for us to use. So one of the things just to prove this is all available and ready to use is I actually had that VPN set up and I have an access point that's joined to that. So you're going to see very shortly, there's going to be an access point that joins. It's going to be seen in the GUI here and it's ready to roll. That access point is traversing that VPN connection that we established earlier and it's already joined and it's got its configuration. Scrolling up here, you see that CapLab state is run, it's joined, it's ready to go. So this is me just making sure I have that trust point set up here to ensure that I don't have any SSL certificate problems when I join again. Now we're going to change management connectivity methods here. So we highlighted the fact that you need to use a key when you SSH into the device here. So I'm just highlighting how you would do that using OpenSSH. So the only difference is we just have to use that cryptographic key as part of this, as an extra layer of security. And that's what I had from a demo here. So what you saw was basically the ability to quickly create your own virtual network, specifically on Amazon Web Services, but we could quickly do this also on Google Cloud Platform, and then instantiate that Catalyst 9800 cloud very quickly and have an access point join. So we're going to change gears, dive a little bit deeper into the Cat 9800 in the public cloud offering. So let's talk about supported authentication modes with the solution here. So first, we support FlexConnect central authentication. Basically, when you associate to the access point here, your EAP traffic is received by the AP and it's sent to the wireless LAN controller. The wireless LAN controller will then talk to Radius, which is basically ICE or a different Radius server back on your local site. So that's occurring through that VPN connection. ICE replies with the authentication result and the authorization policy to the wireless LAN controller in the public cloud VPC that you set up. The wireless LAN controller forwards the reply to the access point. The AP will relay that authentication frames to the client here. So this is a high level traffic flow that's represented here. So basically, once you're authenticated, you're then basically allowed to talk to the local wired network there because we're doing FlexConnect local switching as part of this public cloud offering here. So DHCP occurs locally from that site and that upstream network that's local to that branch. So The next thing is, what happens if we have VPC managed with VPN, and we have local auth capabilities that we need to be able to support here. So we can provide that, but it's only as a fallback mechanism here. So if the AP loses connectivity with the cloud service provider, we could still support Flex Connect standalone mode and then have a local authentication method. That means that the access point can talk to a different radius server within your local network there. So the one thing we need to be able to highlight here is that this EAP traffic still terminates on the AP. It talks to that local radius server that's there. And basically the radius server responds with the authentication result. The AP sends the response to the client. Traffic is locally switched at the access point. But this is only available right now if connectivity to that Cat 9800 in that public cloud is unavailable. So the nice thing about this is there's no additional latency with this, but we don't have full capabilities with this right now. So you can't do BYOD, WebAuth, COA. So that's one of the reasons why we want to highlight this. It's only if there's connectivity problems going to that Cat 9800 controller in the cloud. But one of the great new capabilities that we got with iOS XE 17.2 is the ability to support 802.11r in this model as well. So that's a great addition that we gained recently. So high availability modes and software updates. So we talked a bit about this before, the concept of having a, availability zones, different regions here. So again, we don't support HASSO with the public cloud offering in the Cat 9800. Again, that's because we can only have one IP interface on the virtual appliance in that public cloud. So we have to support N+1 HA. But again, we're doing Flex Connect local switching, which basically has that standalone mode, which allows us to keep the clients connected while we fail over to that standby, N+1 Cat 9800 controller. So basically, we create a wireless LAN control instance in the same VPC, but maybe in a different subnet or a different availability zone, or even in a different region. We associate the subnet with the different zone, and then basically we configure the access point to point to that different N+1 controller to provide us that geo-redundant capability, that failover capability. So this is how we do it. So you can either go into the wireless LAN controller, configure, your primary or secondary on that access point, or you can do this using a scripting or, Yang-based models to basically update this information on the access points. So software upgrades, even though this is in the public cloud, you're going to get like a base image that's associated with it. So one of the things is when I deployed, in Amazon Web Services, we deployed using iOS XE 17.3.1. Well, we're already up to 17.3.2a, available on CCO for you to download. So basically, once you deploy, you then would have to do a firmware upgrade of that wireless LAN controller to get you up to the latest release. So we can easily do that using the traditional methods that you're familiar with today. So you basically download that bin file from CCO, and then you upload it, to a TFTP or a, some type of file server, or maybe even, do an HTTPS upload, using your browser to the wireless LAN controller in the cloud. So basically, it's the same approach that you do today to upgrade the wireless LAN controller, but it's just in a public cloud. The other thing that we can begin to do is maybe you don't want to take the downtime. Well, one of the things we can do is basically you can build a new instance of the Cat 9800 in that same subnet. Basically, what you can do is do a config backup of the existing controller, and then maybe a restore to that new controller that you just built at the new version of software. We can easily support that model too. So we're winding down here. So I appreciate all the attention, all the great questions that you've been posing to the team here. So let's highlight some of the key takeaways that we talked about here. The Cat 9800 is a great virtual option if you don't want to have a physical piece of hardware on your premise. And we support all the capabilities that we talked about that you would have in the physical product for the on-prem version of the virtual footprint. And we can support a lot of the capabilities that you're familiar with in a cloud footprint. So we talked a lot about what you can do, what you should do, and some gotchas that we've learned along the way. So hopefully you don't repeat our mistakes. But something we want to highlight here is there's a lot more information that you can use to, map your journey as you move to the new Cat 9800 in your environment here. We have great in-depth cloud deployment guides and controller installation guides here that you can follow as part of this. And we even have dedicated guides on how you would do this within public cloud providers as well. So you don't have to go this alone. So these are great references that you can use, just basic information on the Cat 9800, especially that deployment best practices guide here. So again, as we wind down here, thank you for investing time with us and the Catalyst 9800. As Matt talked about briefly before, is we had 2 sessions already, basically migration overview, best practices, and how to use Flex Connect on the Catalyst 9800. Those sessions and the content from those sessions are available at the following URL, http://cs.co/9800 migration. That's at the bottom of the slide here. The content from this presentation here will be uploaded very shortly, as well as the presentation videos that we had as well. So you can pause and take a look at what I did during those demos if you have further questions. So I would be remiss to say that, we actually have a couple more sessions out there. March 11th is our next one. How do you migrate using Prime and DNA Center to the Cat 9800? Then we have one on March 25th. How do you troubleshoot using the Cat 9800? Basically, what's the new configuration model? What are the new capabilities like radioactive tracing? And then lastly, we have a couple different offerings here on March 18th, April 8th, and April 15th for basically you getting hands-on experience with the Catalyst 9800 in basically our cloud. So you can basically get hands-on, build your confidence with it, and then, be ready to go tackle those tasks that you have within your own environments there. So thank you for investing your time again and learning about the Catalyst 9800.